So you honors kids probably noticed that I put some ACT stuff on your homework packet. And if I have to do work for the answer, you have to do work for the answer. That's just kind of the way it is. If I has to do work, you has to do work. Okay. Graph of a function y equals f of x consists of 3 line segments, so that would make it a piecewise function, wouldn't it? The graph of the coordinates shown, or the endpoints of 3 line segments, are shown in the standard xy coordinate plane below. What is the area in square units of the region bounded by the graph of y equals f of x, the positive x-axis, and the positive y-axis and the positive x-axis? There's a lot of ways of doing this, a whole lot of ways of doing this. I would probably be tempted to break it up into pieces like this. Some people might do trapezoids, because you could actually see one trapezoid and one triangle, but this is probably the easiest way to do it. And then think about the individual pieces that you created. So this thing goes here, this is 2, 3, this is 0, 4. That means we rose 1. I went from 0 to 2, we run 2. Of course, if you're in honors, you know 1/2 base times height, or you wouldn't be in honors now, would you? So anyways, the area of this little triangle is 1/2 of 1 times 2, and that ends up being 1. So the triangle has an area of 1. I see this kind of fat rectangle right there. It's got a 0.23 on it, which means it runs right 2 and rises 3. It has to have an area of 6. There's this little skinny triangle right here. We go from 2, 3 to 3, 3, so it is only 1 unit wide, and it's 3 units tall, so it has an area of 3. And then there's this larger triangle right here. On the x-axis, we run from 3 to 5, so it has a base length of 2, and on the y-axis, we run up 3. 1/2 base times height. This guy has an area equal to 3. So my areas were 3 and 3, which makes 6, another 6, which makes 12, and another one, which makes 13. Not a hard problem. The sum of two positive numbers is 151. The lesser number is 19 more than the square root of the greater number. Ugh. What is the value of the greater number minus the lesser number? So the sum of two positive numbers is 151. So sum A plus sum B is 151. You can use X and Y if you want. The lesser number is 19 more than the square root of the greater number. So I'm going to let A be the lesser number. It is 19 more than the square root of the greater number. Which one do I need to add 19 to? For equality, I would have to add 19 over here. All right, or I'd have to take away 19 from A. So A minus 19 is the square root of B. Hopefully you understood that. What is the value of the greater number minus lesser number? Well, what I have now is I have two equations. I actually am just going to go back to this. Well, should I? I think this one gets kind of ugly no matter how you do it. Everywhere I see an A, I can replace it with the root of B plus 19. So the root of B plus 19 plus B is 151. So I'm substituting into this line right here. I was thinking about different ways of doing this, but it turns out any way you do this, the algebra is going to be a little bit ugly. I can take away 19. What is that, 132? Seems right. The root of B plus B is 132. What's that going to be? I actually, without doing algebra, I just came up with the answer. B is 121. Maybe you see that, maybe you don't. I just sat there and thought about what B might be. But the root of 121 is 11. 11 plus 121 is 132. But if you don't see things like that, you have to resort to algebra. And the algebra on this one is a bear. It really is a bit of a bear. Do this algebraically. We do teach radicals in algebra 2. You're supposed to isolate the radical. The opposite of square rooting is squaring. So if I square the root of b, I get b. If I square the right-hand side, I get a pretty big number. You'll notice I did it in my head without a calculator, but if I actually do the algebra, suddenly I require a calculator. 17,424 minus 264 b's, and then plus a b squared. And then what I would do is I would shift everything right so that I compare to 0. 0 equals a positive b squared minus 265 b's plus 17,424. And now I need factors of 17,424 that will somehow get me to 265. And I'm going to use that brain of mine and cheat. It's those two right there. 121 and 144. So to be negative, they're both negative. All right. So I get that B is either 144 or that B is 121. It's one of the two. And because A is actually the smaller number, this is kind of funny how this works out. Because A is the smaller number, this is A and this is B. You actually get them both. A is 121, B is 144. Now, what did they want up top? They wanted the difference. What is the value of the greater number minus the lesser number? Oh, sorry. This is not, B is 121. Because it wouldn't make sense over here. If you plugged in 144, this is actually extraneous. That's the extra, okay? If you plugged in 144 right here, the root of 144 is 12. 12 plus 144 is not 132. That's the extra. So B is 121. Real answer. So back up here, 128 plus 121 is 151. That would make A 30, right? The difference between these two, the greater minus the lesser, is 151. Take away 30, which is 121. So that one, if you have to do the algebra, that thing takes way more than a minute to do, doesn't it? It does. One of the following graphs in the standard xy coordinate plane is the graph of y equals sine squared plus cosine squared over the domain negative pi over 2 less than or equal to x less than or equal to pi over 2, which means you're stuck in, well, anyways, never mind that. But over the domain, that's x, by the way, that's x. Crap. They put their pi over 2's on the y-axis. Utter crap. That's what that is. This is actually a really easy problem for anybody who studied the form quiz. You see that guy right there? That guy right there? That's how you do this problem. Sine squared plus cosine squared is 1. So I legit have, instead of y equals sine squared plus cosine squared, I have y equals 1, which is a horizontal line. That's how long it is. It took me a minute to write it out. Would have taken me a second on the real test. 51, the list of numbers 41, 35, 30, x, y, 15 has a median of 25. The mode of a list of numbers is 15. To the nearest whole number, what is the mean of the list? So mean means average. All right. We have a median, which is basically the organized middle. And we have a mode, which is most often. I believe that's how it goes, isn't it? All right, so let's put this list in order. we have 15. And if the mode is going to happen most often, then there's got to be another 15, doesn't it? Doesn't there have to be another one? At least one of these is a 15. That's the only way this can happen. So 15, 15. I don't know what x is yet. 40, 30, 35, 41. I'm going to go ahead and put the x here. It says I have a median of 25. So these two, they need to average to be 25. The only way that happens is if x is 20. So there's a 20 there. This makes sense. Now the mode is 15. We have a median of 25. And now I can find the average of the list. So there's 1, 2, 3, 4, 5, 6 things. I'll do that in a calculator. Hopefully you kind of understand the process of creating that middle number. 15 plus 15 plus 20 plus 30 plus 35 plus 41. We divide by 6. They want it to the nearest whole number, and by God, I got a whole number. It's 26. All right, you are given the following system of equations. Y is x squared, and r times x plus s times y is t, where r, s, and t are integers. For which of the following will there be more than one solution with real number coordinates for the system? Ugh, that's horrible. That is absolutely atrocious. You wouldn't think it'd be quite that easy. I'll be honest with you, if I was taking the ACT at your age, I would think about something that we're going to talk about next week. It's called the discriminant. It says if b squared minus 4ac is greater than 0, there are two real solutions. But it can't be that easy, can it? So what I'm going to do is I'm going to cheat with the calculator here. I'm going to make up numbers for r and s and t. All right. Let's let r be 1, s be 2, and t be 3, and see what happens here. All right. So this equation right here becomes x plus 2y equals 3. To graph that, I would put it in slope-intercept form. Y would be negative x over 2, add 3 halves. So I did mention my TI-84. TI-84s are great calculators. First one is y equals x to the second. If you don't have a TI-84, you should totes get a TI-84. Okay? Just ask your parents. I'm sure they'll be glad to pay for one. See, alpha x brings up my fraction. Now, I say that if you're a college-bound kid, you should definitely have one. There's a difference between kids who have their own calculators and don't. To one of them, it's more meaningful. They actually know more on average. Anyway, so there's my two equations. I went to y equals zoom 6. I would say that thing has two solutions. Wouldn't you? I see two intersections. So more than one. So now I'm going to plug these numbers in and see what happens. So what's true here? R was 1. 1 squared plus 4 times 2 times 3. That's definitely true. Let's see, this one would be s squared. That'd be 2 minus 4. That's not going to happen. This would be r squared minus 4 times s times t. Not going to happen. Not going to happen. Oh, it's that one. So, see, turns out I was wrong. I was thinking about something else. I don't think 4 times R times T. It ends up being this. So I made up something. I saw two solutions. I plugged it in. Spent a lot of time on that. And had I gone with my gut from being 16, 17, I'd have missed it. Third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? You can do this one with algebra, and you will use some algebra to do it. But they tell you the third and fourth term are 13 and 18. That's what they tell you. I wrote them out. The difference is 5, and they want the 50th term. You ain't got this kind of time to waste. You have to know a formula. You have to know that the nth term is the first term plus n minus 1 times the common difference. Plus, you're only at third and fourth. I mean, this would be second, that'd be first. Work your way back to the first term versus working your way forward to the 50th term. If I take away 5, I'm at 8. If I take away 5, I'm at 3. So, now if I want the 50th term, usually I clean these up to make them look like y equals mx plus b, but there's no point. The 50th term would be the first term of 3 plus 50 minus 1 times the difference of 5. And that's going to give me my answer. Should be 248. That seems right, because this is going to be 245. So yeah, 248. All right, what is the period of the function f of x equals the cosecant of 4x? This is actually beyond Algebra 2. We might, and it's a big if, we might graph y equals sine of x. Sine of x has a period that's equal to 2 pi. This 4 right here is what you call a horizontal compression. This thing right here is a horizontal compression. It is compressing the x-axis fourfold. Probably have never heard of a horizontal compression. But if the old graph y equals sine, and I mentioned that because sine and cosecant are reciprocal. So if sine has a period of 2 pi, cosecant has a period of 2 pi. So if we're compressing the x-axis fourfold, the new period is 2 pi over 4, which is pi over 2. And can we cheat our way through that on a TI-84, I wonder? I wonder. If you're in honors, most of you guys have memorized things on your form quiz. We haven't even talked about the trig down here, but you have memorized that cosecant is 1 over sine. At least I think you have. It's right there. Cosecant is 1 over sine. So I can go to y equals. I can type in 1 divided by the sine of x. And I want you to notice that these are all what we call radians. I don't know that you guys talked about radians last year, but you will before this class is over. Go to mode. Make sure your calculator is in radian mode. Do a zoom 6. A period is how long it takes for a graph to cycle. Okay? I'm going to play with my window here. Oops, that was the wrong button. I'm going to play with my window. I'm going to take the window from 0 to pi. X min of 0, X max of pi. And I'm going to hit that graph key. Oh, you know what's wrong? Milbrath's an idiot. It was cosecant of 4x. Back to that graph I saw. That graph repeated itself 2 times. All right? If my original window was 0 to pi, I only need half of that. So that's where the pi over 2 comes from looking at the graphing calculator. 56, at the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded for 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any coin of the toss. What is the expected value? Should be 9/2. Should be. So here's how this works. You flip a penny, you have a 50% chance of getting 3 points. You flip a dime, you got 50% chance of 3 points. You flip, what's the next one? Oh, the nickel. I forgot about the nickel. Flip a nickel, guess what? 50% chance of 3 points. On average, you would expect to get a 1.5 here, a 1.5 here, and a 1.5 there. That's 4.5 points, 9/2. Hope that makes some sense. For what positive real value of k, if any, is the determinant of the matrix that contains the elements k, 4, 3, and k equal to k? Equal to k. That's different. That might be the next one I put on your ACT thing. So I've been teaching you guys how to do this. K times k is k squared. We take away that upward diagonal, 12, and we set it equal to k. And you actually know enough now how to do this. Zero product property, that sucker, right? K squared minus k minus 12 is 0. Factor, we always factor. Factors of negative 12 that add to negative 1 would be, what, negative 4 and something like that? Minus 4, k plus 3. So k is 4 or k is negative 3. Huh. Oh, I don't know why I said huh. For some reason I was thinking that 3 had a positive symbol on it. So there's that one. 58, given a positive integer, ice to the n equals 1, which of the following statements about n be true? Hey, you guys know this. When n is divided by 4, the remainder is 1. That's not true. Boy, you would be really tempted to put that. Give me a minute. Let me pause this. Apparently I'm needed at the door. All right, so back to this. Why did I pick that? Well, because I know exponential rules. Say you had I to the 4th. I've taught you that you take your remainder, or you take your exponent, you divide by 4, and you keep the remainder. I to the 4th is I to the 0 power. Anything to the 0 power is 1. So when n is divided by 4, the remainder is 1. See? Anyways, that's the deal. And why did I pick on I to the 4th? Because they said of this. That's the definition of I to the 4th, 1. So even that, I mean, if you know your measuring numbers, that's an easy one. 2 more to go, then I can break here. For negative pi over 2 less than or equal to theta less than or equal to pi over 2, the absolute value of sine of theta being greater or equal to 1 is true for all and only the values of theta of which of the following sets. So this would be one of those nice things that I wish I could teach some more trig in Algebra 2, because this is a senior test. This is for kids who have taken pre-calc and trigonometry classes. Let's see here. Y equals sine of x. Sine of 0 is all right. I had to think of my starting point here. Hello, Wisconsin. Somebody just hollered, hello, Wisconsin. That's from the 70s show. Y equals sine of x looks like this. All right. Now, if you take the absolute value, this makes everything positive. Well, now, what happens to the graph is it goes up, it goes down, it comes right back up, and it goes down. That's what it does forever. But since they have restricted it on this domain, and we see equality, equality is that one. So for all values of theta such that theta lies between negative pi over 2 and pi over 2. These are actually individual solutions. This is that set builder notation I've shown you in the past. So S choice D, that'd be a tricky question. You'd actually have to have taken a trig class to be able to probably get that. But now you've seen something. And by the way, you know, I just showed you how to do something in a calculator. If you want the absolute value of the sine function in TID4, go to Math, Num, Sine X, because maybe you don't believe Milbrath. Milbrath doesn't know what he's talking about. The window here was from negative pi over 2. They told you the window settings here. They told you the domain restrictions to positive pi over 2. You'll see I'm typing them in. And then graph. Mine's not the same because of the y-axis. When I graphed mine, I had a y-min of -1 and a y-max of 1. And I think I actually went out from 0 to pi. But I was trying to show you what happens to the graph. It's always positive. So there you go. All right, 60, which is probably the easiest thing on this test. Ray PK bisects angle LPM. The measure of angle LPM is 11x and the measure of LPK is 4x plus 18. What is the measure of KPM? A lot of stuff on there. So we have some angle that is called LPM. Ray PK cuts that thing right in half. All of this from here to here is 11x degrees. L to P to K is 4x plus 18. And if L to P to K is 4x plus 18, I forgot the 18, this piece is also 4x plus 18. This is like half of what geometry was, adding two things together and setting it equal to something else. And they want the full measure of KPM, so we're going to solve for x. What we know about 4x plus 18 and the other 4x plus 18 is that they add to be 11x. X is on one side, numbers on the other. There's a 36 on the left when you add your 18s. 4 and 4 is 8. 11 minus 8 is 4. 3, and my x value is 12. So, what's this dude right here? It's 4 12s, add an 18, which is 48 plus 18, which is, what, 66? That seems reasonable. So there's all the ACT questions. A lot of that was over your head. That's okay. How else are you going to get it if I don't teach you stuff that's not in this class?